Just live with that. Okay, so quadratic equation. Okay, so let's go all the way back to the beginning. And when we think about quadratics, and how do you know it's quadratic? Your variable is squared. First off, you're going to think, hey, because the degree of the polynomial or the equation is a second degree, two solutions. And then you got to think, okay, how do I solve a quadratic? And what should pop in your mind is, I can factor and solve by factoring. If there's no x to the first power term, or if I have a quantity, I can take the square root of both sides, method number 2. Or method number 3, I can use the quadratic formula. Most call it the quadratic equation. Your book calls it the quadratic formula. That's the third way. And again, this needs to be in your thoughts. This needs to be your thought process. Hey, it's quadratic. What am I going to do? Am I going to factor, setting it equal to 0? Am I going to take the square root of both sides, or am I going to use the quadratic equation? All right, so how do you use the quadratic equation? Well, first off, you got to understand that it uses the values of A, the value of B, and the value of C of standard form. So it's got the letters A, B, and C in the quadratic equation. And where do you get the A from, the B from, the C from? The A is the coefficient, the multiplier of the squared term. The B is the coefficient, the multiplier of the x to the first power term. The C is the constant when it's set equal to 0. So be careful. It's got to be set equal to 0 to read the value of C. And so that's the A, B, and C of the quadratic equation. All right, you got to know those, and that's the only way. All right, so number 2, use the quadratic equation to solve. Really, the idea is when you can't use the other two methods. Because quite honestly, the other two methods are quicker. However, I will say this. Can any quadratic be solved by the quadratic equation? The answer is yes. So it can solve anything. So let's see, go back to, I think it was Josh's question yesterday, how can you check this thing? So we were completing the square. We were coming up with roots and solutions by completing the square. And the question was, how in the world can you check these answers? And it would be really difficult to put them back into the original. I mean, you could. But how else can you? You can use another method to solve. So if you solve by factoring, or solve by taking the square root of both sides, you can check it by using the quadratic equation. When would you do that? Again, after you're done with every question, right? You would never do that in the process of taking a quiz or taking a test. You're going to run out of time. But if you're done and you want to use your time wisely and you want to make sure you're correct, you could go back and check. All right, so don't forget the other two methods, and I've mentioned them already a couple times now. To factor, setting the factors equal to 0, and to take the square root of both sides. Okay, so how does the quadratic equation, what does it look like? All right, so start off with green because the b comes first. It's negative b. And by the way, this is something I require you to memorize, so just memorize it. I don't provide the quadratic equation for you, so you're going to have to memorize it. And I think we probably got to this in Algebra 1 toward the end of the year. I don't know if anybody remembers it, but it's negative b plus or minus the square root of b squared. Then comes a minus. I've added these parentheses this year because, to be quite honest with you, this back part of the radicand is what students mess up on. I mean, they'll know what numbers to put in for each of the letters, and they'll have all the right numbers in the right place, and then they'll go to finish the thing, and they'll end up with the wrong answer because they mess up the radicand. And I really think if you put the parentheses there, you're not going to mess up the radicand. So it's minus then 4 times A times C, and that's all divided by 2A. So negative b plus or minus the square root of b squared minus 4ac all over 2a. Notice the plus minus will give you the two solutions, right? because we're solving quadratics. Second degree, we're expecting two solutions. The plus minus is going to give us the two solutions. In some instances, we'll leave our answer in this kind of form, and in some, we'll keep going. For example, let's go back to the homework. So you can see here number 30. That is in the quadratic equation format right there, as is number 22. The form of the answer looks just like the quadratic equation, as does number 18. For some that could be solved other ways, the quadratic equation could end up giving you something like 14, negative 610. So the plus minus stays sometimes when you can't go any further, and in other times when you can go further, that'll be gone. All right, so anyhow, you got to memorize this, memorize the quadratic equation. And so to help you memorize it, every time you write a problem for the homework tonight, write the quadratic equation. All right, every time you got to write a problem for the homework, just write the quadratic equation as you try to then help you, hopefully, to memorize it. All right, so solve the following using the quadratic equation. You can see I used color. Should make it easy. It's already in the right format. X squared minus x minus 12 equals 0. Are those ones going to be there normally? No. But you know that the A is a 1, and hopefully you know that the B is a negative 1, and the C is a negative 12, right? For some of you, it would be to your advantage to do that off to the side, to just say what A is, B is, and C is. For others of you, you're fine with that. You'll put the right numbers in, and you don't need to do that. But I'm just telling you, some of you, you're better off to the side saying what A is, saying what B is, saying what C is. All right, so right off the bat on a problem like this, the first thing students miss is there's a negative as part of the formula, right? And therefore, the first term is minus a minus 1, right? The negative of the formula and the negative 1 of the B value. The negative of the formula and the negative 1 of the B value, right? Minus B. So don't miss that. That happens often. Students will miss that. Okay, then the formula says what's next is the plus or minus, and then the radical sign. Again, I have a b squared. I'm putting it in a parentheses. It's another place where you need to be careful. If you punch into your calculator negative 1 squared, go ahead and punch it in. Just punch in negative 1 squared. No parentheses, no nothing. Just do negative 1 and then squared. And see what your calculator says. Some calculators are going to say 1, and some calculators are going to say negative 1. So what does your calculator say? How many say negative 1 on their calculator? How many of your calculators say 1? Okay, so there's a few calculators. Well, what is the answer? It's 1, right? And that's, again, why that parentheses needs to be there, because you're squaring a negative 1. So be careful with that. That's another pitfall of the quadratic equation. Okay, what comes next? The plus minus. And again, I think if you use a parentheses here, you're going to be in shape of 4. What's the value of A? Boring. That's a 1. What's the value of C, though? Be careful here. That's a negative 12. And this is all over 2 times A, which is a 2 times 1. Okay, so we've got all the values in. Josh. Yep. Are you talking about right here, Josh? Right here? Yeah, that's just a negative. That's part of the formula. And that is right. Oh, I put plus minus. No Kool-Aid for Josh. Everybody else Kool-Aid. All right. Actually, I should have done it this way. Thank you, Josh. Someone's awake out there in TV land. Okay, so that is a minus, right? No plus or minus there. Okay, So let's go ahead and fool with the radicand a little bit. Hopefully you agree this front number is going to be a 1. And the back quantity ends up a negative 4 times a negative 12 for a positive 48. Do you agree? And I chose an easy one to get us going here. So the front number is now going to be a positive 1, right? Negative and negative is a positive. Plus or minus. We all know the square root of 49 is 7. And then it's all over 2. And by the way, we could have solved this by factoring. But we're learning the quadratic equation. So at this point, because you can go further, you need to split it up. So use the plus one time and use the minus the other time to get the 2 roots. Right? You got to split it up. Solve it with the plus sign, solve it with the minus. So what do we get? X equals 4 and x equals negative 3. So you don't need to do this, but by the way, if we would have factored this thing, we would have said negative 4 plus 3. We would have set each factor equal to 0 and said x equal negative 3, x equal 4, right? And of course, it should solve the same way. So normally a problem like this, you would solve by factoring. We use the quadratic equation because we're learning the quadratic equation. All right, let's go on. Okay, so same scenario. So let me pause. Why don't you go ahead and put in the values this time. All right, so hopefully you ended up with 3 halves and negative 3. Right? So you can check along the way where you may have gone awry. You should have had the square root of 81, which should have given you a 9. So negative 3 plus or minus 9 over 4. Split it up. Negative 3 plus 9 over 4, negative 3 minus 9 over 4. 3 halves and negative 3. Any questions on that? Anything I can clarify for you? Be careful in the radicand. Usually that's where the mistakes are made, unless it's minus and minus. Okay, let me get rid of my shade so I can go higher for you guys. Okay, so next example. So you look at that, and when a student looks at C, if they're too quick to write A, B, and C, or if they just go ahead and start off on the quadratic equation, we're not quite in the format yet, right? This is x squared plus 2x plus 3 equals 0. Okay. Now again, some of you don't need to write what A is and what B is and what C is, but A is a 1, B is a positive 2, and C is a positive 3, right? Remember, an x squared is a 1x squared, so it's not 0, it's a 1. All right, so now we're ready to sub in. Negative b, so that's a negative 2, plus or minus the square root. V squared, so that's a 2 squared, minus, I'm going to use that parentheses, 4. You can put the 1 in there if you want, but times 1 is kind of boring. But feel free to put it in there if you want. Then we got a 3, and this is all over 2 times 1, which is a 2. So hopefully you agree that's where we're at. If you look in your radicand, that's a 4. And this is going to be a negative 12. So the radicand is a negative 8. Which everybody's now thinking what? What are you thinking? Imaginary, right? We got an imaginary solution. By the way, imaginary solutions are always conjugates, meaning They're two binomials, and the sign in the middle is different, and it'll be the plus minus. All right, so we got to finish this thing out. X equals, I don't know why I switched to blue, doesn't really matter. Okay, can you simplify the square root of negative 8? Again, right, that's a negative 1 times a 4 times a 2. So really, you get a 2 out, you get an I out, and you got the square root of 2 left in. We'll move the I in a minute. And we're still over 2. Right? And the last thing we need to do is simplify this thing. Okay, so everybody watch, because this one you may not make the mistake on, but students do this all the time. So just watch. This is what students do. And the good ones that make a mistake do put a 1 up there. And they say the answer is negative 1 plus or minus 2 times the square root of 2i. But that's wrong. Because if you had this, negative 2 plus 2 over 2, the answer is 0, correct? But if you do this, what do you get? You get 1, and that's definitely not the solution, and you can't do that. Now, if you remember that you're technically supposed to split it up into 2 fractions and divide the 2 in there and divide the 2 in there, oh, now you get 0. So don't make the mistake, and students often do. They often forget. Oh, it's not working lately. They often forget that you have to divide it into both. So if you're going to simplify this in this format, it's got to divide into both. I'm going to write it out this first time just to remind you. Right? You're supposed to divide the 2 into the front term and the 2 into the back term. If the top would have been a trinomial, we would divide the 2 into all 3 terms of the top. And by the way, this also gets you in the right format, because now what do we end up with? Negative 1 plus or minus the square root of 2, and I don't like the I in the back, but technically it goes in the back. Most will let you get away with I times the square root of 2 in the back, because again, it's more clear when the I's in front of a radical. And there's no fraction, so there's no fraction bar to get it across from. So negative 1 plus or minus I times the square root of 2. And again, notice they're conjugates. Negative 1 plus I times the square root of 2 is one of them, and negative 1 minus I times the square root of 2 is the other. Okay, 2 solutions that are imaginary. All right, last example. Solve stating both the exact solutions and the decimal round-offs to the 100th. Okay, so not a problem. There are occasions when you'll want a decimal round-off. You know, in real life, if you were using an equation like this, most of the time you are trying to get this value to plug into something else, 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 to maybe ultimately somewhere down the road get an answer. Do you want to round off? No. You want exact answers because you're plugging this into this, into that, into that. And if you round off now, this answer gets a little bit further from the exact answer, and this one's even a little bit further more, and this one's even a little bit further more, and so you don't want to round off. However, if this was the last step and it's the last value you needed, and you want to know, for example, what was it last night? How many seconds the thing was, whatever. Okay, well, we want to know how many seconds. We don't want to know like 7 times the square root of 5. We want to know like 3.2 seconds or whatever. 7 times the square root of 5 would be more like 15 seconds. So if that's the case, then you'd want a decimal round off. All right, so this one asks for both. So let's just go ahead and solve it. Pretty simplistic. Move the 2 to the other side, right? And of course, you all have the quadratic equation memorized. Negative b plus or minus the square root of b squared minus 4ac all over 2a. I noticed Brian was in here earlier, so when you see him in the hallway today, I want you to stop him and say, Brian, tell me the quadratic equation. Let's see if he remembers it. Just curious. He might. He should. Think he will. All right, we'll see. All right, so again, we're just going to solve this thing. And for some of you, you need to list A, B, and C. All right, negative B, so B is 8, negative 8, plus or minus the square root of 8 squared. I could just write a 64 because I know what I'm doing at this point, right? I'll do the other part, minus 4 times 3 times negative 2, all over 2 times 3, which is a 6. So negative b plus or minus square root of b squared minus 4ac all over 2a. So we got negative 12 times a negative 2 is a positive 24. So we got a positive 88. 88. Yuck. How in the world ever figured this problem out? 4 times 22 for an 88, right? So all of this is 88, which is a 4 times a 22. So where are we at right now? X equals negative 8 plus or minus square root of 4 is 2 times square root of 22 all over 6. Here's the way I would simplify this. Most people that do the shortcut, just make sure whenever you simplify, it goes into both, right? Both terms. So 2 goes into negative 8, leaving you a negative 4. 2 goes into 2, leaving you a 1, right? So what are our exact answers? X equals negative 4 plus or minus the square root of 22 all over 3. All right, go ahead and finish it out. Go ahead and find the round off solutions. So you just got to use your calculator. Negative 4 plus the square root of 22. Divide that quantity by 3. Negative 4 minus the square root of 22. Divide that quantity by 3. And you'll get the 2. And remember, we're going to the hundredth, right? 10th, hundredth. So 2 decimal places for those that don't know what the hundredth is. But you do. You do. All right. What do we got? 1.79. Anybody else get that, I hope? 1.79. Anybody? Anybody? 1.7. No 1.79s? How about negative 4.46? What? All right. What are the two answers? Alex, what are the two answers? Anybody else get negative 2.44? 3 of you? All right, I better punch these out. Alex, what's your second answer? Anybody else get 5.56? 2 of you? Oh, well, Marissa's got it, so I know those are correct. All right, I mean, what? Why are you laughing? All right, so you got to navigate your plus minus button. You got to get the whole numerator and divide it by the whole denominator. 0.230, right? 0.230. How many got 0.230? Okay. All right. And the other, and what did I just do? Probably the plus, right? Plus minus button, plus 4, plus minus button equals, divided by 3 equals, negative 2.90. Okay. Okay. So 0.230 and negative 2.90. Hey, what's the moral of the story? If they do ask for exact, be careful punching in. You got to navigate through square roots. You got to navigate plus minus buttons. All of that. You can either use parentheses. And remember, it's the whole top divided by the bottom. So you got to sum the top before you divide the bottom. All right, you got 5 minutes left. Joanna. You know the way I do it? I did square root of 22 first. Minus 4 equals divided by 3. The second time, minus. So the second way I did it this way. Square root of 22, you should have a plus minus button on your calculator. So square root of 22, then I did my plus minus button. Now some calculators want you to do that first. So I did it second because my calculator let me, then minus 4, add it, divide by 3. You got to add the top before you divide by the bottom.